guys, today's lesson is on system of three equations word problems. So we're going to have three equations with three variables. We have to first write the equations and solve them to then solve the word problem. The first three are dealing with relationships of three different numbers in which we'll write a system and solve it to find out what those three numbers are. Our first sentence in problem number 1 is the sum of three numbers is 16. We're going to go ahead and represent that using x, y, and z for our variables. And since the sum of them are 16, we'll say x plus y plus z equals 16. The next sentence says the largest number is equal to the sum of the other two. So at this point, we need to decide what our largest number is. I'll say that the largest number is going to be z. So the largest number is equal to the sum of the other two numbers, which would be x plus y. And lastly, it says 3 times the smallest number is 1 more than the largest. I'll say that x is my smallest number, and it says 3 times the smallest number is 3x is 1 more than the largest. The last equation, I used z as my largest, so 1 more than the largest would be z plus 1. Before we begin, as you could see, not all three of these equations necessarily line up the like terms. So what I'm going to do is fix the second and third equation. So the x term is first, the y term is second, and the z term is third, all on the left side of the equal sign. So I'm going to go ahead and just copy the first equation, x plus y plus z equals 16. The second equation, I'll subtract the x and subtract the y over to the left-hand side, or you could always just subtract the z, so we could get x plus y minus z equals 0. That's another option. And the third equation, I'll subtract z. As you can see, the third equation doesn't have a y in it. Therefore, how many y's are there? There would be 0 y's. So when I write this equation, we'll have 3 x's plus 0 y's to have that placeholder in the equation. I'll subtract the z over, and that would equal to 1. Just like our last lesson when we were solving the system of three equations, the first step would be to take two of the equations and eliminate one of the variables. What I'm going to do is I'm going to take the first two equations and add them to eliminate z, since that seems like an easy step for us to do. So we would have x plus y plus z equals 16. And x plus y minus z equals 0. If we add these together, we get 2x plus 2y, the z's will cancel out, equals 16. We know we have to save this equation for later, so you should either highlight it or put a circle or box around it so we know in step 3 we're going to use that equation. However, the second step is now to use two different equations and eliminate the same variable. I already used the first and second equation, so this time I'm going to use the first and third equation to eliminate z again. I'm going to go ahead and copy the first equation, which is x plus y plus z equals 16. And the third equation is 3x plus 0y minus z equals 1. If we add these equations, we'll end up with 4x plus 1y, the z's will cancel out, equals to 17. So the first two steps, we got our two equations with two variables. Step 3 will be taking these two equations and solving the system of two equations to find x and y, and then we'd be able to use those to find z. So what we're going to do is take those two equations, 2x plus 2y equals 16 from step 1 and 2, and 4x plus y equals 17, and solve this system. We're already set up for elimination, so I'm going to use that method, although you could also use the substitution method by solving for the second y and substituting the expression into the first equation. I'm instead going to multiply the second equation by 2 and subtract to eliminate the y. So our two equations would be 2x plus 2y is 16, that's the first. And multiplying the second by 2 would give us 8x plus 2y equals 34. Subtracting is going to give us negative 6x. The y's will cancel out. And 16 minus 34 is giving us negative 18. We'll divide to solve for x, in which we find that x is going to be positive 3. So we found one of the numbers. Let's go ahead and use that to find a second number by substituting it back into one of the equations of two variables. I'm going to choose to do the second equation we have. So if x is 3, I know 4x plus y equals 17, or 4 times 3 now plus y is 17. 4 times 3 is 12, and subtracting the 12 over, we're going to get y is 5. The last step is to find our last number. I'm going to take an equation, one of the first three equations we made over on the top left. Any of these three would do. We want to find z, so I think the most convenient would be the second equation that says z equals x plus y, in which we know x is 3 and y is 5, therefore z is going to be 8. Therefore, our three numbers are going to be 3, 5, and 8. The next thing I'm going to ask you guys to do is try number 2 and 3. I'm going to start you off with the equation for all three equations for number 2, and then let you practice 2 and 3. For number 2, the sum of three numbers is 24, so we'll represent that as x plus y plus z is 24. The second equation says twice the smallest number is 2 less than the largest. I'm going to say that the smaller number is x, so twice x is 2 less than the largest. I'm going to say z is the largest, so that would be z minus 2. And the last part says the largest number is equal to the sum of the other two. I already said the largest was z, so we have to use z in the last equation to represent the largest. And the sum of the other two would be x plus y. In number 3, the sum of three numbers is 18, so we're going to represent that as x plus y plus z is 18. The sum of the first and second number is 15, so I'll say x plus y is 15. And lastly, the first number is 3 times the third. The first number here is x, so that would equal 3 times the third is z. What you guys are going to do first is make sure you put all the terms with x, y, and z over to the left side of the equal sign, and then go ahead and solve the system. Pause the video. Once you get your answer, go ahead and play it back. Here are your answers for number 2 and 3. Number 2, we're going to get the values 5, 7, and 12. When you subtract all the numbers or move all the terms to the left-hand side, we should get these three equations. And remember, if one of the variables is missing, you could just put a placeholder in and say that there are 0 of that variables, as we did in the second equation. The first and second step would be to eliminate a variable, in which I decided to eliminate z as we did in the first problem. That would then give us two equations that we would solve the system for the two equations with two variables, giving us x is 5 and y is 7. And lastly, we would substitute those into one of the original equations to get z is 12. Similarly, for number 3, again, when you're moving all the terms over to the left-hand side, if there's a missing variable, you should substitute a 0 in as a placeholder, like the equation number 2, we have a 0z, and the third equation, we have a 0y. And in this case, your three numbers should be 9, 6, and 3. Let's check out this last problem here together. We have Mike is doing a math quiz that has 2 hours. Oh, God. Let's check out the last problem here. It says Mike is doing a math quiz and has 2 hours. It takes him 5 minutes to complete a multiple choice question, 5 minutes to complete a calculation question, and 10 minutes to complete a word problem. In this case, the 3 items we have, or the 3 different variables we have, I'm going to represent as x, y, and z, representing the multiple choice questions for x, the calculation questions as y, and the word problems for z. So this is going to help us make our 3 equations. Since it takes him 5 minutes to complete a multiple choice, I'm going to say that would be 5x plus 5 minutes to complete a calculation question, that would be 5y, and 10 minutes to complete a word problem, that would be 10z. In total, he has 2 hours, it says, that he has to take this quiz. So we're going to set that equal to how many minutes is 2 hours? That would be 120. We're going to make 2 more equations. The second sentence says he must complete 20 questions and as many multiple choice questions as calculation questions and word problems combined. So if he has to do 20 questions in total, that would be the multiple choice questions plus the calculation questions plus the word problems, and there would be a total of 20 problems or 20 questions. And as many multiple choice questions, which is x, as calculation questions and word problems combined. So the multiple choice questions would be the same amount as the calculation questions, or y, plus the word problems, or z. Now that I have our 3 equations, I'm going to go ahead and convert the third equation so that the y and the z are all on the left side by subtracting. So my first equation is going to stay as 5x plus 5y plus 10z is 120. X plus y plus z is 20. And I'm going to subtract the y and z to get x minus y minus z equals 0. Let's go ahead and solve the system by taking 2 equations and eliminating a variable. The first 2 easiest ones to use, I think, would be the second and the third equation. I'm going to use addition, and I'm going to eliminate the y's. There's many different ways you could go about this, and if you eliminate a different variable, you wouldn't be incorrect. So I'm going to take the x plus y plus z equals 20, the x minus y minus z equals 0, and I'm going to go ahead and add them. Coincidentally, in this case, we're going to have x plus x is 2x, y plus negative y is 0. We're also going to eliminate the z's because z plus negative z is 0 equal to 20. This is actually going to allow us to find x. By dividing 2, we know that x, or the multiple choice questions that Mike is going to complete, is 10. We're going to continue on with the next step, which is to take 2 other equations and eliminate another variable. I'm going to now take the first and the third equation. I'm going to rewrite the first equation, 5x plus 5y plus 10z equals 120, and multiply the second equation by 5 to eliminate the y's. So we're going to get 5x minus 5y minus 5z equals 0. I'm going to go ahead and add to get 10x. The y's will cancel out, plus 5z equals 120. The convenient thing about the 2 equations we have left over is that since we already know what x is, we could use it and plug it into this equation to figure out what z is. So if x is 10, I know that 10 times 10 plus 5z is 120. Or 100 plus 5z is 120. I'll subtract 100 to both sides to get 5z is 20. And now I know that z, which represents the word problems, is 4. The last variable we need to solve for is y, or the calculating problems, in which we can now just take x and z and substitute it into one of the original equations. I'm going to substitute it into the second equation. That seems to be pretty easy. X plus y plus z is 20. I know x is 10. I don't know what y is yet. And I know z is 4. So from here, we could solve for y by combining the like terms to get 14 equals 20 and y equals 6. As our answer, we would answer as to what the variables stand for in terms of what Mike completed on his quiz. So X means multiple choice. We know that Mike completed 10 multiple choice questions on his quiz, 6 calculating problems, and 4 word problems. Please let me know if you guys have any questions. And